this question, a system is described by the following state equation. The matrix P, Q and R is given. We want to take the controllability and observability of the system. Options are given. Option A, controllable and observable. B, not controllable but observable. C, controllable but not observable. And D is not controllable and not observable. In standard form, the controllability matrix QC, that is given as Q, PQ. And the rank of this matrix should be 2. Since this is a second order system. Since the order of P matrix is 2 by 2. And observability matrix QO, that is given as R transpose, P transpose, R transpose. The rank of this matrix should be 2. The value of determinant of this matrix should not be equal to 0. Then the system is observable. The value of this determinant should not be equal to 0. Then the system is controllable also. Value of this matrix Q is 0, 1. We can obtain the product PQ, that is minus 1, 3. So the value of this determinant QC, that is equal to 0 into 3 minus 1 into minus 1. That is equal to 1, not equal to 0. So the rank of this matrix is 2. So the system is state controllable. Now we can take observability. That means observability matrix QO, that is given as R transpose. So 0, 1. Then P transpose, R transpose. We can obtain the value of P transpose, R transpose as 0, minus 3. So the value of this determinant QO, that is equal to 0. So the rank is only 1. So the system is not observable. So option is controllable but not observable. C is the right option. A system is described in state space model. Since A matrix is a 2 by 2 matrix and we have 2 states variable, so the order of system is 2. We want to find the steady state error of this system when subjected to a unit step input and options are given. First we can write the given data. We have A matrix that is equal to 0, 1, minus 1, minus 1. And B matrix is given as 0, 1. And C matrix is 1, 0. Okay. And steady state error, that is given as ESS, that is equal to limit t tends to infinity E of t. This can be obtained by making use of final value theorem. This is equal to limit s tends to 0 s into E of s. That is equal to limit s tends to 0 s into R of s divided by 1 plus g of s h of s. This is our steady state error. We can write Si minus A matrix. This is equal to S0, 0, S minus our A matrix, that is 0, 1, minus 1, minus 1. This is equal to S minus 1, 1, S plus 1. Since this is a 2 by 2 matrix, so inverse can be obtained by interchanging the main diagonal elements and changing the sign of off diagonal elements that divided by the determinant of this matrix. The value of determinant del. Here del is equal to S into S plus 1 plus 1. That is equal to S square plus S plus 1. T of S, that is equal to 1, 0. Then the inverse matrix, that is S plus 1, S 1 minus 1. This divided by del. So we can write del here. 1 by del into this. This into B matrix. That is 0, 1. So this is equal to 1 divided by the value of del is S square plus S plus 1. This into 1 into S plus 1. S plus 1 plus 0 into minus 1. So first element becomes S plus 1. The second element becomes 1 into 1 plus 0 into S. That is 1 and 0, 1. Now multiply these two matrices is equal to S plus 1 into 0, 0, plus 1 into 1, 1. So value of this is equal to 1 divided by this s square plus s plus 1. So our transfer function is 1 divided by s square plus s plus 1. Standard form of a transfer function t of s, that is equal to g of s divided by 1 plus g of s h of s. This is given as 1 divided by s square plus s plus 1. Convert into standard form. I am dividing the numerator and denominator of this term by s square plus s. 1 divided by s square plus s whole divided by 1 plus 1 by s square plus s. Now comparing this equation with this one. So we can write g of s, that is equal to 1 divided by s square plus s, and h of s, that is a unity feedback, that is equal to 1. And our input is a unit step signal. So r of s is equal to u of s, that is given as 1 by s. Steady state error, that is equal to limit s tends to 0, s into r of s. R of s is replaced by 1 by s. That divided by 1 plus g of s h of s. G of s is 1 divided by s square plus s, and h of s is 1. Now this s and s get cancelled. So substitute s is equal to 0 in this equation. We get 1 divided by 1 plus 1 by 0. That is equal to 1 divided by 1 plus 1 by 0 is infinity. So this is equal to 1 by infinity, that is equal to 0. So when excited by a unit step input, the steady state error in this problem is 0. So A is the correct option.